Welcome to the FarmBits podcast, a product of Nebraska Extension Digital Agriculture. I'm Jackson Stansel.
And I'm Samantha Teaton, and we come to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews and panels with experts, producers, and innovators from all sectors of digital technology, we hope that you step away from each episode with new practical knowledge of digital agriculture technology. Welcome, FarmBits followers, to the 43rd episode of the FarmBits podcast.
We are continuing on in our precision crop protection series with this episode and are focusing on spray application technology.
For this episode, we're joined by Sam Marks, who is a current PhD student in the Biological Systems Engineering Department here at the University of Nebraska, Lincoln.
Sam did his master's at UNL and went on to work at Capstan Ag before returning to Nebraska to start his PhD.
At Capstan, Sam worked on a variety of projects and was the engineering lead on an aerial application technology project.
In this episode, we will get into all things spray control, from ground rigs to aerial applicators.
Spray control is a critical topic in crop protection, so let's get right to our conversation with Sam. So will you please tell us a little bit about yourself, your background, how you ended up back here in Nebraska as a PhD student?
Sure. So my name's Sam Marks and from Wisconsin originally. A little background on myself. I got my undergrad in something called Ag Engineering Technology. It's a non-ABET accredited sort of engineering tech program from University of Wisconsin, River Falls. From there, I actually went in the Peace Corps for a while. And when I was there, I decided I wanted to do grad school. So I looked into different ag engineering programs. I really wanted to get that ABET accreditation. So ended up finding UNL as one of the top contenders. So I reached out and talked to Mike Kocher while I was in Africa. And when I came back stateside, I met with him and decided, hey, this might be a good fit. But because I was from Wisconsin and I had a lot of remedial courses to make up, I ended up living in Broken Bow, Nebraska. So kind of out in the Sandhills. Got a job there so I could gain residency in the state. And I was a precision ag consultant for a group of John Deere dealerships who at the time were independently owned, then bought out by Plains Equipment. And now I think they're called Acres. It's been a while since I've kind of kept too much focus on that, but I did that for 3 years in Broken Bow. Started working on some courses while I was there. It was through the community college. It was a lot of long lunch hours, but it was good. It was a good experience. I got to work with just a multitude of operations, operators, different methodologies. It was actually really neat to see the diversity, even within one community of the different practices that can be had. So from there, came to Lincoln. It took me 3 years to get my master's degree because I had to do a year of basically the 300, 400 level engineering courses, which was a nightmare as an adult learner. It was really tough. I just kind of went through that program, and at the time met my wife. We got married while I was in grad school and got a job down in Topeka, Kansas at Capstan Ag. I had a little bit of background in sprayers, had an internship many years ago where I spent a summer spraying. It was an interesting summer. And then, so I just, and even at the precision ag side, I got to stay involved with some spraying technology. So it was kind of a good fit. So I worked there for 4 years. And while I was there, I just have an insatiable hunger for wanting to know more. And at one point in time, someone at the company said, you might do better in academia. So just after some thought and some discussion, the project I was working on, we got it to a point where it was now commercially available. So I felt okay about kind of passing the torch there and decided to lead Capstan. And I got a research tech position here, as well as working on my PhD, and I'm about 2 years into that now. So
Awesome.
It was just kind of a long, strange road of poor decisions that led me to this. So,
And unique experiences, I guess.
yeah. So that's kind of why I came back, I guess. I really like to learn. I like to know more. I think there's still a lot that can be done in the industry, specifically in the spraying world.
Yeah.
And there's not a lot of people working on it in the ag spray world. So, especially on the technology side now. So I thought that's kind of a neat little niche to fit into.
Absolutely.
Yeah.
So do you mind telling us a little bit more about what exactly your role at Capstan was and some of the projects that you worked on? I know you mentioned one that you got to commercial availability.
Yeah. So when I started there, I did a little bit with liquid fertilizer application systems, just trying to come up with, there was a lot of issues with dynamic responses. So I did a little bit with that. But about not even quite 6 months after I started, I got involved in their aerial project. It was more of an idea at the time. I started by going up to Canada and strapping a ground rig pinpoint system on a helicopter. And we basically made it do section control on a very high resolution. So instead of half boom, which is what they had, we were able to do every 3 nozzles. So we did, I think they were spaced at 12 inches. So we did like a 36-inch resolution at 60 miles an hour, which was a pretty cool feat. So again, that was using all ground rig stuff. We had, I think it was a Trimble display on there. So we were using the section control of that. But that got us kind of thinking into the world of aerial spray. So that same fall, I went to the National Ag Aviation Association convention and just started asking questions. And I met with a bunch of pilots. I met with pilots afterwards, and that kind of formulated sort of a plan of, direction that we needed to head. And yeah, so I was the engineering lead on that project for 3.5 years. So we focused on fixed wing ag aviation, so the high speed turbine powered aircraft. And we eventually came up with a PWM system that was enclosed within a boom shell, that we could basically, we were still kind of in the learning stages at the time, but we could do pressure control, rate control. We could turn different nozzles on and off. So unlike a ground rig where you have to have that overlap of your flat fans, you could have sets of 3 nozzles. And so one could be a large droplet, one could be a medium droplet, and one could be a small droplet. You could put deflection on one. So if you want to do fungicide, you have that at a 45-degree angle, only turn on that nozzle. Now you have a very fine droplet being sprayed. If you want to switch over, you don't have to go turn nozzles anymore. You just poke a button on a display. It changes your profile. And then you could go out and spray, a contact herbicide. So it was kind of a neat project. We had a lot of heartache trying to get it to work, because on a ground rig, you can be in the sprayer and you can see what's happening and you can diagnose on the go. Whereas in a plane, you have to load it up, pilot takes off, goes and sprays a little bit. You can be on the contact, over radio or cell phone to an extent, but it's still not the same as seeing what's happening. And then they land, you discuss things, figure it out. Well, every time you take off and land, that's not only time consuming, but it's pretty pricey as well. Yeah. So we were blessed with some really good cooperators that just helped us figure out what we needed to do, how we do it. So it was a really neat project. And that's mostly what I focused on. So, yeah.
Yeah. So it sounds like you have a lot of experience working both with aerial applications and ground rigs. I guess one of the things that I'm kind of curious to learn more about would be like pulse width modulating nozzles and variable orifice nozzles, things for spray control. Can you give us kind of an overview of how those systems work?
Sure. So the main concept of PWM is it's not about like coverage per se. So the whole premise behind PWM is pressure control. So you can select a nozzle that you can basically decide what droplet category you want to spray. And now you can maintain that pressure and flow, but alter your speed, I guess you could say. So on the ground rig side, think about it as when you're entering or exiting your headland, you speed up your sprayer. Well, normally the only way to compensate is to increase your pressure. Well, as pressure increases, now your droplet size decreases because your hydraulic atomizer generates a different atomization profile. So with PWM, instead of increasing pressure to maintain GPA rate, you can actually increase your duty cycle. So you maintain pressure. So if you want 40 PSI to be your target pressure, because you know that sprays the category you want, now you can speed up. It increases duty cycle to increase your actual flow rate to maintain your GPA, but maintain the desired droplet size that you want. So it's actually a pretty clever technology. It's been around since the late 80s is when Ken Giles first did some work on it at UC Davis, did the patent on it, and then Capstan bought the patent from UC Davis. And now you see it commercially available on every major OEM, plus a lot of the smaller companies as well. So PWM in its most basic form, that's what it does, is it maintains your droplet size through the field. So when you apply that to an aircraft, it's kind of the same idea to an extent. The range of operation isn't quite as big because you're going so fast that some of those things aren't the same. So you don't speed up to go into a headland. If you slow down on your turn, you die. So so there's some interesting differences there. On the where it really comes into play in the aerial world is, if you want to increase your swath width, or if you want to spray at a different rate, there's some different caveats there that PWM was really useful for. So if you want to get a different droplet size, so nozzle plays a huge part, not just nozzle size plays a huge part in the droplet size creation on the aerial world with that secondary air shear. So maybe you want to run a different nozzle that normally you couldn't because it would be outside your flow rate scope. But now you can pulse that, have adjacent nozzles pulsing, so you still get that blend. So there's a lot of different things that you can do with PWM on the aerial side as well. But yeah, on the ground side, it's pressure control. That technology was advanced in the early 2010 era, where they did pinpoint, where Capstan did pinpoint. And the cool thing there is it had turn comp in it. So think about a 120 foot sprayer. As you turn, if you're turning left, your inside nozzles are going slower. Your outside nozzles are going a lot faster. Well, now you can change that duty cycle across the entire boom in sort of a diagonal pattern. So your actual GPA application on the field can remain a lot more consistent than if you didn't have that turn comp. So little things like that just got built on over and over. And I think that's, to me, still one of the biggest advantages to PWM is its kind of versatility. Variable orifice nozzles or variable geometry nozzles. So Veritarget would be one. I think those are great in a specific situation. I'm not as familiar with them. The idea there is you have a nozzle that sprays your whatever fan angle it is, and then it can maintain a droplet spectra. So even if you increase pressure, it still maintains that same droplet spectra. So you can do flow changes over a speed change, I guess. I read, I'm trying to remember where I read it. I think it was Tom Wolf from, I don't know if you're familiar with sprayers, sprayers101.com.
Yeah.
So I think he had something written about, if you look at kind of your coefficient of variation across the boom, well, pressure has a quadratic relationship with flow. So as that pressure changes, it actually has a more or an increased change on your flow rate. So if you have just a little bit of discrepancy even between nozzles, you could be spraying way more on one nozzle than the other, or at the end of your booms where you're getting a pressure decrease. So I think there's some things there where I think the technology has a lot of promise, but I don't see it widely adapted, are adopted. And I think that's probably one of the reasons why. So I don't know, does that answer your question? See, I forgot already what our question was.
Yeah, I think you covered it pretty well. I thought it was really interesting about the point you made about the headlands on the field. That's a real problem area, especially with weed control. And I can see where this technology could be a big help for, preventing anything like, excess herbicide rate causing a carryover issue, and then also ensuring that you have, good coverage of the area, those headlands, if you're turning or something.
Yeah.
To be sure that your coverage is good and your efficacy is also.
Yeah, that's where it comes down to. If you can get what you want on target every time, weed resistance is going to start to diminish. Over application, which can be a problem for, say, runoff, or, there's a lot of little caveats that can come in with that I think just getting the right amount of spray on the right part of the field is really important. And I think that's where PWM does a good job. I think there's technology that could come out, or that's kind of on the verge of coming out, that I think could really help with that as well. So,
and do you think there are any like drift reduction effects of PWM and stuff like that? I know you didn't necessarily mention that directly, but if you're able to keep that profile the right way, I would imagine that helps with drift. Right?
So the dirty D word, yeah. So yeah, you don't necessarily want to say drift reduction. Well, I guess you could say drift reduction, but drift mitigation is kind of the right term to use there. So that's exactly right. So if you can maintain pressure and spray at what you actually, what the label says, what you want to be spraying, now you're not increasing pressure. Well, hydraulic atomizer, if you increase pressure, you're creating a smaller droplet.
Sure.
Or your atomization profile, the curve is basically shifted over into the smaller range. So yeah, definitely that helps with drift mitigation. Absolutely.
Mm-hmm. Yeah, that's got to be a big deal right now, especially with all that we've heard about dicamba drift and all these other issues that are going on in agriculture. But I guess kind of talking more on this interplay of aerial applicators and ground rigs. You mentioned like the secondary air shear and kind of the uniqueness that plays with spray planes. What are some of those challenges that have to be accounted for on these different application platforms that kind of force changes in the technology, or even the way that technology is implemented?
Sure. So I'll just give you some really basic examples in the aerial world. So the secondary air shear, basically it starts with initial droplet out of your hydraulic atomizer, and then depending on that size, that air impacts it and it blows into smaller droplets. So things that have a big play on that secondary air shear is fan angle, deflection angle, and pressure or exit velocity of those droplets coming out. So if you get closer to matching your exit velocity with your actual air velocity, so that relative velocity is decreased. So that has a big impact on that secondary air shear. So one of the things that happened in the aerial world quite a while ago was, if you look at spray planes or crop dusters from way back in the 30s, 40s, 50s, they have these huge vortices coming out the end.
Sure.
Right now, it's a rule that you can have a boom width of no more than, I always get a little bit mixed up. It's either 75 or 65. I'm pretty sure it's 75% of your wingspan.
Okay.
So basically what you're doing there is, if you look at the science behind that wingtip vortice, right around the wing, it says it'll trap, X diameter of droplet. So let's say it's a 300 micron droplet. As you expand out of that vortice center, that axis of that vortice, that droplet size decreases. So as you get out.
Sure.
So the idea there is if you can just get those droplets away from those vortices, now there's less potential for them to be trapped up inside of that wingtip vortice. So even doing something as simple as reducing boom width, I think it was found that you could actually maintain your swath width because you still get that wake pushing the spray out, but now you're not getting that stack up in the middle. So instead of having this pattern where it's, you want a nice trapezoidal pattern. Well, with wingtip vortices, you get a big spike in the middle, or it takes those smaller droplets in whatever direction your wind is and pushes them off. So even little things like that have made a big impact on actually getting spray on target. So yeah, I know a lot of people see a yellow airplane flying in the sky and they're like, oh man, curse the devil.
Yeah.
But a lot of thought has been put into how can we get the spray where we want it to and be as efficacious as possible without off-target movement. And I think there's still a lot of work in there. Another one was using a flow control. So they don't call it rate controllers for whatever reason they call them flow control. But the idea there is now instead of using wind speed, you can actually use a GPS, figure out ground speed, and it adjusts your pressure to match your ground speed. So if you're flying with the wind, if you have a 5 mile an hour headwind, which usually a lot of guys spray with a crosswind, it just makes it more consistent.
Sure.
But say you need to fly into a headwind. Well, if you have a 5 mile an hour headwind, you have a 10 mile an hour difference pass to pass airspeed, but your ground speed is going to be the same. Your ground speed is going to change, but your airspeed will be 10. Your airspeed will stay the same, but your ground speed will be 10 miles an hour different. So even just being able to control your flow for that has been a big benefit.
For uniformity, yeah.
Exactly. Kind of lost the question again there.
Just kind of, just think about some of these, the differences that you have to deal with between aerial and inbound.
Oh yeah. That air shear is the biggest thing. There's air shear and air movement. There's so much happening behind that aircraft.
Mm-hmm.
You don't have fold up landing gear on at least most of the commercial, the air tractors and the thrush, even the egg cats, I guess. They don't have folding landing gear. So wheels, booms, dropping the booms down from behind the wing made a big difference. You don't have that on the ground rig sprayer where it's all this different stuff, ground effect. If you spray too close to the ground, it'll actually pillow that spray out. If you spray too high, it could move off target. So there's so much happening there. And you kind of get to know when you watch these ag pilots that have been doing this for a number of years, like they just know where their spray is going, and they're really good at just getting the right height, the right speed, and they just do it. And
for the environmental conditions.
Yeah, too. It's so fascinating, to watch that. And especially, these high powered turbine aircraft, they're going 160 miles an hour, 10 feet off the ground, 10 to 15 feet off the ground. So, the old adage was you want to see crop in your wheels. And I think that's starting to change, or probably has been. It's been a number of years since I started looking into this stuff. Yeah. But it's, I think I heard someone say once, it might have been Dennis Gartz, or I don't want to put words in his mouth, but I believe he said it's like a third of your boom width is the height that you want to be spraying.
Okay.
Don't quote me on that.
Just rule of thumb, something like that. Yeah.
Yeah. So that secondary air shear is a big part of it. Orchard spraying, similar. You have that air blast pushing across that hydraulic atomizer. It shears that droplet. Well, now you've just got spray going everywhere, and they're doing huge rates. Huge rates, hundreds of gallons to the acre. So you think about that impact. If you're creating very small droplets and it's a windy day, that could be a very bad deal.
Exactly.
My next question will kind of gear towards the difference between aerial and ground rigs again, but more from an integrated pest management perspective. I can think of some examples of pests like two-spotted spider mite in corn. That's a bottom-up pest in the corn canopy, and you really want to protect the middle part of that corn plant, about ear height. Then there's other pests like fusarium head blight in wheat. You're trying to protect the head. So only pretty much the upper canopy. I'm just curious about technologies and the difference between aerial and ground rigs. What types of technologies are there out there to deal with different challenges with pests that might be in a different, have a different target and
kind of the canopy penetration.
Sure. So I know that there's been some different studies done on like electrostatic spraying, where they used a very small droplet, the electrostatic, and the evidence showed that there was some bottom. Basically, it would attract that spray to the bottom of some. It was in cotton that they did that. They might have done in other ones as well. The problem there was the electrostatic rate that they were spraying was like a third the label rate, so it's already a non-starter. But it showed, promising results. So there's a disconnect there between what's on our label and what our technology can physically do. This is where I'm probably not, I would say I'm not the expert here, but, there's people that know a lot more about canopy penetration. So if you have a higher pressure on a ground rig, theoretically that creates a higher velocity spray. Well, that higher velocity is going to shoot it down into the canopy. Ideally, you get some of those smaller droplets would kind of pillow back up and get the underside of your leaves. But on the aerial side, that would be something I would have to ask some of my pilot friends, because I'm not familiar with how they manage doing something like that. So that's kind of a non-answer, but I think that's going to be really dependent on the application and the applicator. As far as technology goes, I think it's just trying to match what we have to what needs to be done, I could think of other things like the spray hoods that might try to trap that spray in there. I can't remember the name of the sprayer. It's a European one. They have an air assist where it basically helps trap that spray. That would get it down into the canopy. So are there technologies? Yeah. Do I know about them or how to use them specifically for what you asked? No, I'm not your guy, unfortunately.
That was an interesting example, though, the electrostatic spray boom. That sounds pretty cool. I don't know. It might have to be promising.
Yeah, there's some skeptics that say you'd have to, what did someone tell me? You'd have to drag a ground rod with your airplane to actually make it work. But again, I'm not an expert in it. I just read some papers, and the evidence showed there was some efficacy or some chemical on the bottom side. It was a fluorescent tracer dye on the bottom of the leaf. So it might have just been because it was small droplets and they came back up like we see with, higher pressure shooting down into the canopy. I don't know.
Yeah. Dragging a ground rod seems like it might be kind of a challenge to get over power lines at the end of the day.
I think that could be an issue. Yeah.
So you kind of mentioned earlier when you went up to Canada and you were working on a pinpoint system on a helicopter. And I guess there's a ton of buzz right now in ag about variable rate applications, not just for fertilizer, but also starting to look at some of these crop protection products. Can we only put it in certain areas that feel that need it? We have soil type changes, or we have different hybrids in different areas. How can we get that variable rate wise on that field? So what really is a reasonably achievable resolution for these aerial applicators to get to, and what is the technology that enables that to happen?
So with standard, just flow control and nozzles, I don't know, I'd have to run some math on that to see. You can make fairly quick changes. Sure. I think there have even been some people down in like the Mississippi Delta that have done variable rate application using like a satellite flow control. I think PWM, when we were running some numbers on that with the capstan swath pro system, I'm just spitballing some numbers here, but I think we had it figured out that we could make a rate change in about, it was either 5 or 10 feet.
Wow.
Yeah.
At 160 miles.
Even at 100, I think that was using 150 miles an hour. And so basically you have this 100 millisecond delay time between your pulses.
Sure.
So if you do 100 milliseconds and figure out what that is in feet per second, it was somewhere around that 5 to 10 feet area that you could do a rate change. So pretty significant. That's actually something, one of our first beta operators, when we put the system on, when you turn your flow off, you can either hit a button which will shut your pump off, or you can actually pull your suckback lever, and that actually diverts your flow back up to your tank, and it pulls a suction on your boom. So the idea there is you're not dripping out.
Sure.
And when we switched it over to those nozzles or those PWM solenoids shutting off, he actually had to adjust when he turned them on and off because he was leaving gaps at the end of the field. Like it was
that fast.
It was about 10 to 15 feet different than what he was used to. So it was a pretty interesting deal. Yeah. So technologies like PWM, I think, that was one of our value statements, albeit the industry is still not quite there with wanting variable rate pesticide application.
Mm-hmm.
But I think as that time comes around, I think there's already technology out there.
It's going to be equipped to do it.
That could be ready to do that. Yeah, you could throw a script in right to that spray plane, and it could make that change relatively quickly.
Sure. Wow. That's amazing. I was thinking if they're moving at 150, 160 miles an hour, I mean, you got to think there's going to be a reasonably long rate change time. But like you said, actuation, it is quick.
Side story here. Yeah. During our beta testing once, we actually, so normally you want your nozzles, your adjacent nozzles to pulse 180 degrees out of phase. So you get that overlap. Our software got loaded in and it told all the nozzles to pulse at the same time. And I got a picture from that pilot as he was flying over the field. It was gramoxone, and about 2 days later, you can see very visibly, and you could see the checkerboard, like you could see it plain as day.
Man.
And when we went out and walked that field, I calculated up before I left, what his frequency was, what his speed was, and we walked the field, and it was within a foot.
Wow.
Of that actual. So you could see the live dead, and it was within a foot of my calculated distance. So to me, that was really kind of a good, even though it was a horrible mess and, he had to respray the field and it cost thousands of dollars and it was a nightmare. It was like, hey, we learned something here.
Right.
That was really cool. So
make sure that you're always 180 degrees out of phase.
Yeah. Yeah. And just knowing that a calculated distance,
it actually adds up.
It adds up. It works. So that gives me confidence in saying that 5 to 10 feet is achievable with PWM.
Sure. I mean, if you have that sort of ground, it's pretty hard to argue.
Yeah.
Within the series, we're kind of talking about aerial applicators and what historically people have perceived to be aerial application technologies, your helicopters, your planes. Rantizo is another guest that we had. We had Sam Pendleton from Rantizo on the show earlier in this series, and he was talking about UAVs and how they're starting to work into kind of this aerial spray package. What do you think are the challenges for optimizing spray patterns with UAVs? Can some of this same technology actually be implemented on UAVs, or is it too bulky to kind of go on to those systems? What are your thoughts there?
So there's actually a lot of work being done in that area. It's a little outside my knowledge base, but I've been involved. There's RPAS, RPASS is another an organization or just I'm not quite sure what they are, but anyways, they hold a yearly conference and it's people coming together to address actually these specific issues. Like, okay, how do UAVs work for spraying, spot spraying, broadcast spraying, you name it. So there is a lot of research being done. There's pattern tests, ability coming out. When they first came out, I remember watching a video from, I believe it was South Korea, and this UAV was spraying, 6 or 8 feet above the canopy with it was like a 110.03, just a really fine droplet. And that stuff was just going everywhere. And it was like, oh, that's so painful to watch, because that's the opposite of what we want to see.
Absolutely.
The problem with things like PWM, at least, again, it's been a couple of years since I've been there, but in its current form, I think it's too heavy because you have to have a controller, which you could probably control 1 or 2 nozzles with a small PCB microcontroller and repackage that. But even the solenoid itself is pretty heavy, so that reduces your payload capacity. But I think there's a lot of potential there. There's some talk about like variable geometry orifice or something of that nature. So I think the big thing is still trying to figure out what are we using it for? What kind of droplet size do we need? And then what kind of nozzle can produce that without all of these underwash? If you have 4 rotors, the pairs are running counter rotation to each other. Sure. So your disturbance underneath that is pretty nightmarish in all honesty. And there's even some people doing some CFD work on that topic to try to figure out, can we look at this downwash and maybe use it to our advantage. So I think there's a lot of people in that realm that are really working hard at making a good use of UAVs. I see a lot of promise in them, specifically spot spraying, opening fields up. If you have a condition that, say it's a small field and you can't go in it because it's too wet. If you don't have a helicopter around, well, you don't want to fly an airplane over that. So what's that leave you? Historically, it may just go untreated, but now there are at least options there.
Sure.
There's some thought about swarm UAVs going out. I think it still comes down to payload, how long your battery lasts, and just, the actual efficiency of them. But again, this isn't really my area of expertise. Sure. So I think there are people that are like really working hard to answer these questions and make it work. So I'm excited to see where it goes. I think there's a lot of promise there for sure.
Yes. So I think that's really good feedback, especially like after hearing from Rantizo, because I think it's a lot of the same things, but it also points to some of the challenges, right, that you have to still address, and it may not, be easy to say from the commercial side sometimes. So now we've kind of covered like all these different application technologies that are currently out there, and kind of starting to get into what people are working on next. What do you think are some of the major challenges that we need to try to address, kind of be like priorities for us to address as a spray industry? And what do you think are some of the most exciting opportunities to actually advance technology to meet some of those challenges?
So my number one thing, and this just goes from being out in the field, is operator training. I know that's a sad thing to say, but in all honesty, you get these co-ops, and I don't want to dog on co-ops. Some of them are great and they train their people extremely well. I just think back to my days in the co-op where I was, here, read through this book, go take this test. Oh, look, you're a certified applicator. I drove an old F-350 pickup sprayer, and I think I got like a half-hour rundown on it, and then I was set free. I had no idea what I was doing. I'm willing to bet that I probably sprayed a lot of chemical off target, wrong rates.
Sure.
Shoot, probably in the wrong spot sometimes, So I think operator training and making sure that we have a consistent, we're actually spraying again, it goes back to this on target spray. So spraying the right thing at the right time at the right place is huge. Environmental conditions sometimes impede upon that. Cost impedes upon that. But I think that would be our number one fix to chemical waste, reducing that, reducing off-target movement. Just, to me, those are the big things. That's the number one thing, is operator training.
Right.
Technology to help that. I think there's already a lot of technology in place that, as far as the research side goes, I don't know if they're all commercially available. But there's research that's been done where you can have wind speed as an input, and you can change the spray that's coming out. That's something I'm actually working on as well, is for given wind speed, altering what's happening out of a nozzle. So there's advancements on that, where if that was all automated, well, now operator training might not be as important.
Sure.
We have, I didn't have GPS on my F-350 either. I had an old Raven 440. It was a monster. So, if we have automated site-specific applications happening, well, now we can be more precise with that application. And operator training may now just be, this lever makes the sprayer go forward and backwards. You show up in a field and it could do everything else. There's some hesitancy to that because, we still see people spraying in conditions that aren't ideal, and they don't want anyone to know that they were spraying in 15, 20 mile an hour winds when they shouldn't have been making that application, because they just have to get the acres done. But I think if we could get to a point where maybe we're automating stuff a little bit more and operator training isn't as necessary. I think a lot of the technology's there.
Sure.
I think we're there. It's just kind of enabling it.
Right.
So,
Makes sense.
Yeah, so if we go that direction in the future towards more automation for spray operations, I could see where that could really be beneficial as far as like making sure the applications are, on target at the right rate, making sure things like sprayer cleanouts happen when they're supposed to, when time management is really important during the growing
Logistics
season.
and record keeping are huge in that world. And sometimes, again, operator training, they're just not done.
So some of like the automation things that, like, what kind of future for automation do you see for, like, how will that change, like spray application, like from an operation standpoint? Will we have more smaller sprayers that are more automated, kind of working together, or will we go more towards more speed, ground speed? I mean, like, where do you kind of see that operation going?
That's a question that a lot of people haven't answered, including myself. You can try to run some numbers and figure out, it would take, it would take this many smaller machines at this price point, running this fast 24 hours a day versus the one guy spraying this many acres in a 12-hour span, so on and so forth. I don't know. I'm hesitant to answer that just because there's advantages and disadvantages. And I think if there was a clear-cut answer, we'd be there because the technology's there. Like we could automate a sprayer and have a swarm of small sprayers go out and spray. There's liability there because now who's to blame? Was it the algorithm? Is it the guy that loaded it? Is it the company that developed it? So there's so many unknowns that part of me would love to see that happen, but I don't know if I ever will, if that makes sense. I hope I do. I hope I hope I can see outside of a research environment, a swarm of robots going out and just doing its thing and everyone's happy. That would be great. I just, on a large scale practical side, I don't know. There's a lot of questions there, I guess. Yeah.
I think those are all really, really good points. And sometimes it's easy to think that the technology availability is what really drives a lot of the adoption and advancement of the industry. But really, it's how does that technology interplay with a lot of the regulations, red tape, and also perceptions that are out there with people. So
perceptions. I'm going to side story again.
Yeah.
So I read a book once, and it talked about the adoption curve of you could apply it to new technology, and it's to be fully adopted. It's like a 20-year time span. So in your first 2 to 5 years or something, you get like 2%. So it's those early adopters, the people who are just curious. They don't care what it costs. They're like, hey, let's try it. And then that curve basically increases, but it takes about 20 years. And PWM is actually a good example there. It came out in the late 80s, prototype idea. It was commercially developed 94, 95, mid 90s. And it took until the mid 2000s before every OEM had it on their sprayer. So it makes sense.
It does. Yeah. I mean, it's definitely reflected in pretty much a lot of the data out there.
So anything you see promising, just realize it might be 20 years before we see that widely adopted.
It's amazing. So we're talking a lot about the future, and I guess, one thing that Zach and I kind of talked about previously was your PhD research and kind of where that's fitting into the future. So would you mind telling us a little bit more about that PhD project and how you're kind of having that fit into the advancement of the spray application industry?
Sure. So I'll tell you why I ended up doing what I'm doing. I would go to wind tunnels and do nozzle testing, high-speed wind tunnels, and I would stare at nozzles on the back of an airplane, and I would watch GoPro videos of it, and it would just, I don't know, there was something about that atomization process that just made my mind go, that's really interesting, and I'd sure like to know more about it. I think there are people doing that in the industrial side, automotive injection, diesel injection, industrial applications, so spray coatings, spray drying. There's a lot of research being done there. And I think the nozzle manufacturers, ag nozzle manufacturers are also doing a lot of research in-house, but there's not a lot publicly available. So I was curious more than anything. So what I've decided to do is actually start looking at some CFD simulation, so computational fluid dynamics simulation of spray nozzles. So I found a commercial package, ended up taking a bunch of classes that were really hard, that I probably still don't understand as well as I should, to try to get a better grasp of the fluid dynamics and fluid mechanics happening at this nozzle. And basically what I'm trying to do is simulate this. So I found this package that you can actually generate the spray where it has the waves and the blobs and the cool stuff. And then when it hits a certain aspherity, when it's round, it basically takes that and says, you are now a round particle of this size. And then it captures that and continues to move on. So the cool things there is you can actually generate like some droplets, like an atomization profile. It's slightly different than what we see when we do wind tunnel testing, but I think it could be correlated. But the whole idea here is, okay, well, if I can simulate reality, or at least get kind of close, now I can start making changes to that nozzle geometry, and I can start to see, well, what has an impact on what. Again, I would be willing to bet someone from TJET could probably school me on this in an instant. But I'm not seeing much out in the public domain. So I think being able to look at, okay, what impacts this spray atomization profile, and then start transitioning that. I have a keen interest in high-speed aerial application, as you're probably well aware by now. What kind of changes can we make on that nozzle geometry that would have a large impact on that aerial side? And there's no one doing it in the ag aviation world. So to me, it's just an exciting opportunity to see how can we better what we have going. I think there's been a lot of progress made in the last 30, 40 years, but even the nozzle guys in the aerial world will say, yeah, we could do better. Let's figure out how to do better. Let's make this, our atomization profile a smaller curve. Let's narrow up our relative span so that we're only spraying to focused droplet sizes, so on and so forth. So that's kind of my ultimate goal. Will I reach that in the PhD? Definitely not. Just learning the simulation package and learning the mechanics and doing a little bit of initial validation is probably where I'll get. But that kind of opens the doors to, what's next. And let's take a deeper look at what we can do rather than going out and machining a nozzle, testing it. Oh, that didn't work. Machine a new nozzle, test it. Machine a new nozzle, test it. Or 3D, it just opens up those doors. You can use additive manufacturing now. I could make a star-shaped nozzle if I wanted and 3D print it. Well, before I do that, I could always put it in a simulation and see roughly what's this going to do. Are we close here? So that's kind of my goal. Big picture is being able to take a look at, can we do better? And I think with my practical experience in the spray world, I'm hoping that'll kind of help play a part in that overall goal. So
awesome.
Yeah.
Yeah. So outside your spray atomization projects, are there any other projects or interesting technologies that you get to see on a day-to-day basis?
I am pretty enveloped in the world of sprays. Every now and then I'll talk to other people about what's happening, but yeah, unfortunately, I'm so overwhelmed with spray stuff that I just kind of put blinders on and ignore the rest of the world, probably to my detriment. But I think, if I wanted to look back into the precision ag world, I don't think it would take me long to jump back in and kind of see stuff. But yeah, I don't know. I love going to farm shows because even though it's not necessarily, cutting edge research wise, it's still cool to see some of the new stuff coming out. And I haven't been to one in a couple of years, so hopefully that's
where Harvest Day is coming up.
I was going to say this fall I plan on going to some, and there's a big spray one specifically in Illinois every year. Probably won't make it to that one, but Yeah. So unfortunately, I don't have a clue what's happening outside the spray world. I'm totally oblivious.
Yeah. It's all right. You have to develop expertise somewhere.
Yeah.
So you seem to have a few really good stories. Do you have any stories from down your time down in Louisiana or Mississippi where you kind of were able to identify, or maybe, up in South Dakota, something like that, where you're able to identify some barriers to adoption of new technologies that you were trying to put on aircraft?
Perception.
Yeah.
If the operator perceives that it's not going to work, it won't.
From the
work.
very get-go, no matter how much.
Yeah. It will not work. And ran into that with one operator. I don't even remember his name. Hopefully he never sees this. It was just really frustrating, because even when we were putting the system on his plane, it was just like trying to find holes in it. And it was a little frustrating, So I think perception plays a big part into that. And, even thinking outside that specific example, where does perception come from? The coffee shop down in the corner gas station, these guys talking, watching, oh, did you see Joe out there? What's he using? So, I think perception, both positive and negative, play a big part in adoption, whether it works good or not. I think someone believing in it or not believing in it is going to be the ultimate factor, unfortunately, for at least, some of the initial crowd. I think down the road, when there's clear evidence that, hey, this is the thing that works, then that's definitely going to lead to more adoption. So,
that's super interesting. So are there any particularly good resources that you would point our listeners to if they'd like to learn more about spray application technology in general?
University Extensions actually have a really good baseline. I know UNL, the Precision Application Technology Lab out of North Platte, they have a lot of good extension publications out there, a lot of good data sets, just general knowledge. So if you're outside of Nebraska, look at your local extension for whatever land-grant university has that extension program. If you're interested in ag aviation, NAAA.org.com, National Ag Aviation Association. They actually they have a lot of information on their website. They're the whole point of the NAAA, kind of to my understanding, is to advocate for those ag pilots.
Gotcha.
So they actually, they're in DC trying to make sure that they're not being phased out. So there's a lot of resources there that just help kind of affirm that aviation is not a bad thing. The yellow plane in the sky is not just some dumb noob up there, making cool tricks. So, sprayers101.com, Tom Wolf out of Canada. I only met him once. Very, very smart guy. And they have some fun videos as well as just really informational stuff on their website. So, and they start at the base level of spraying and work their way into numerous different applications. So those are kind of the three main ones that I would probably look at.
Sure. It's really good.
Stay off of, what is it called? Ag Talk or whatever, the forum.
Ag Talk forum. Yeah.
That's the first place I go.
Some of those guys have great case studies, but some of them, it's just painful to read, because it's just their opinion with no evidence, like any forum.
Right.
So, I think especially with the internet, we have so many resources at our fingertips. It's amazing. So,
get a whole education online.
You can, you don't have to pay for it, world. No, just so,
So one of the questions that we ask in every single interview is if our guest has any advice. And so in this case, I'd like to ask you for any advice that you might have for those who are either thinking about pursuing careers in spray technology, or just those maybe pilots or farmers out there, applicators, who are trying to improve their spray operations in general.
Well, I think in the spray world, there really aren't a lot of people. especially on the academic research side, with a focus on spray technology. So there's still things to be done. We're still learning. So I think that would be a useful thing if there's any interest there. As far as operators, farmers interested, I don't know. That's so hard for me to answer because it's so case by case, and everyone, it's easier to have a one-on-one conversation with someone with a specific question, which I'm happy to answer. World, on, hey, I'm doing this thing. What do you think? And if I don't know, which I'm not the expert on many things, as I've hopefully very clearly stated, but I know a lot of people in this little niche world that we have. So I think finding the right person to talk to is a big deal, and making sure that you're getting good factual data, not just someone's story from whatever. So yeah. So as far as advice goes, I don't know. I'm not very good at giving advice. So be true to yourself.
Yeah.
I'm just kidding. I have no idea.
Getting life advice now.
There you go.
Thank you very much to Sam Marks for taking the time to join us here on the FarmBits podcast. I actually hang out in Sam's office pretty much all the time. His desk is right next to mine. So we spent a lot of time together, but it was really great to hear his expertise kind of in this format, being able to present a lot of the technologies that he has helped develop. I really thought my favorite part of the episode was hearing about the aerial applicators and how we're able to achieve such high resolutions, and you provided a case study of where some of those gaps were in the field and they didn't quite have the blended pulse technology working correctly. But I couldn't believe that we're able to get to 5 to 10 feet of rate change resolution for a vehicle operating at 160 miles an hour over an airplane. It makes me feel pretty good about the future of variable rate technology, for air applicators in the future.
Yeah, that was very impressive. I guess my favorite part was also about the difference between aerial applicators and ground rigs and all the different technologies that are used or applied into both those two systems. I think a lot of times there's kind of a perception that aerial applicators might be the way we did things yesterday and ground rigs are kind of the way in the future. But I think that from what we covered today, we kind of saw that there's technologies that are being applied to both those systems, and there's a place for each.
Absolutely. No, I think you're spot on with that. And I hope that our listeners enjoyed this episode as much as we did. I thought it was a super interesting episode. Next week, we'll be coming in with another episode in this Precision Crop Protection series. So we'll hope you tune in for that. Thank you very much.
Thank you for taking the time to join us today on the FarmBits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback, so if you have comments or questions for us, please reach out to us over email, on Twitter, or in the review section of your favorite podcast platform. Our contact information can be found in the show notes.
We'd like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond.
The opinions expressed by the hosts and guests on this podcast are solely their own and do not reflect reviews of Nebraska Extension or the University of Nebraska-Lincoln.
We look forward to you joining us next week for another episode of FarmBits.